All right, let's dive right into this explainer and uncover the secret, highly technical language that orchestrates every single commercial flight you take. Whether you're a frequent flyer, a window seat enthusiast, or someone who just marvels at the sheer logistics of modern travel, you know there's a whole world operating just out of sight, making sure everything goes exactly according to plan. Have you ever wondered what the pilots, the dispatchers, and the air traffic controllers are actually talking about behind all that technical jargon? It sounds like an impenetrable code to most of us, but it's actually the very framework that keeps us safe. Today, we're going to crack that code.
To make sense of it all, here's our flight plan for today. First, the aviation alphabet soup. 2, rules, pilots, and paperwork. 3, mapping the runway. 4, navigating the open skies. And 5, the invisible safety net.
Section 1. The aviation alphabet soup. The raw data.
This stuff is unapologetically dense. We're talking about 9 specific acronyms, ranging from AIRP to ASDA. To the average passenger, it might as well be an alien language, right? Just a total wall of letters. But the crazy thing is, every single one of these holds a completely non-negotiable piece of the aviation puzzle.
So, how do we unpack this so it actually clicks? Well, we're going to demystify these terms by mapping them onto a timeline. We'll turn a dry dictionary list into a living, breathing narrative of your next flight. We're starting at T-24 hours on the ground, advancing to T-10 minutes on the runway, and taking it all the way up to T+1 hour, cruising high in the clouds.
Moving on to Section 2. Rules, pilots, and paperwork. Ground control. Look, long before an aircraft ever pushes back from the gate or before you even pack your bags, honestly, we have to establish the legal foundation. We've got AME, ANO, AOC, and AIS. These 4 represent the absolute bedrock of pre-flight certification. Without them locked in, nobody's getting off the ground.
It all starts with the human element, the AME, or Authorized Medical Examiner. This is the highly specialized professional who signs off to guarantee your pilot is physically and mentally fit to fly, way before they even glance at a flight plan.
Now we have to understand the crucial difference between the ANO and the AOC. It's the legal framework holding the whole industry together. The ANO, the Air Navigation Order, represents the overarching fundamental rules of the sky. Think of it as the big, governing rulebook of aviation law. The AOC, on the other hand, the Air Operator Certificate, that is the specific, hard-earned license granted to an airline to legally operate its fleet. Basically, the ANO sets the rules for everybody, and the AOC proves that a specific airline is actually competent enough to follow them.
Rounding out the pre-flight paperwork, we've got the AIS, the Aeronautical Information Service. This is a constantly updating, vital data service ensuring everyone operates with the exact same aeronautical updates. Think of it like the ultimate live bulletin board for the skies. If a runway is closed for maintenance or a navigation beacon suddenly goes dark, the AIS makes absolutely sure the pilots and dispatchers know about it before those jet engines ever spool up. Section 3. Mapping the runway, the physical geometry. As we step out of the office and out onto the actual tarmac, the physical airport introduces some truly fascinating real-world geometry. And that geometry is captured by the RASB and the ASDA. We're officially shifting focus here from legal documents to physical space, where math literally guarantees a safe departure. First up is the ARP, the Aerodrome Reference Point. This is essentially the official, fixed, geographic center of the airport. It's the exact coordinate used for all the overarching navigation to that specific facility. So when a complex flight computer maps a route from across the globe to your destination, it's aiming straight for the ARP. It's the mathematical anchor for the entire sprawling complex. Now, what's incredibly cool about this next one is how it translates pure physics directly into safety. The ASDA stands for Accelerate Stop Distance Available. Next time you're pinned to your seat while your plane is speeding down the runway, think about the ASDA. This metric calculates the exact distance a plane has to accelerate to takeoff speed and, critically, still have enough runway left to slam on the brakes and safely abort the takeoff if an emergency pops up. It's literally a physical margin of safety painted right onto the concrete.
Section 4. Navigating the open skies. A new set of rules.
Okay, we've safely cleared the runway and we are climbing into the blue. Here, the terminology shifts again, from physical concrete to spatial mapping and communication. We're looking at AMSL, ARN, and AIREP, the crucial tools managing the immense, invisible 3D space way up above the clouds. Let's start with one you might actually be familiar with, AMSL, or above mean sea level. When you've got thousands of planes flying at hundreds of miles an hour in every direction, they desperately need a universal baseline so their paths don't intersect. AMSL guarantees that every single altimeter in every single plane is measuring its height against the exact same global baseline, the sea. It doesn't matter if you're flying over the jagged Rockies or the flat Atlantic Ocean, 30,000 feet AMSL means exactly 30,000 feet for everyone. Once they reach that cruising altitude, flights don't just wander around randomly. They follow the ARN, the ATS Route Network, where ATS stands for Air Traffic Services. This network acts like an incredibly complex, totally invisible highway system in the sky. There are intersections, specific airways, designated lanes. It's exactly how air traffic controllers maintain total order and efficiency across the globe, making sure everyone stays right in their lane.
And while they're cruising along that invisible highway, pilots don't just sit quietly. They're constantly filing an air rep, or an air report. They feed real-time weather, turbulence, and operational data right back to the ground. This brilliant setup creates a live, crowdsourced map of the sky, helping all the planes flying miles behind them to dodge sudden storms or patches of bumpy air. It's just a continuous, collaborative loop of communication.
Section 5. The invisible safety net, connecting the pieces.
As our flight journey comes to an end, we can really see how these seemingly disjointed terms function perfectly together. What initially looked like an intimidating, dry list is actually a comprehensive, invisible web. It's a web of rules, data, and geometry completely surrounding your travel experience. I mean, without the AME, you don't have a certified healthy pilot. Without the precise calculation of the ASDA, you don't have a safe runway departure. Without the ARN, you just have absolute chaos in the sky. It is all brilliantly, seamlessly connected.
So, I leave you with this thought. The next time you hear the jet engines roar and you feel yourself get pushed back into your seat, what are you going to be thinking about? Will you be thinking about the pilot's AME certification, the airline's rigorous AOC, or maybe you'll be trusting the exact calculation of the ASD keeping you safe right before liftoff? Aviation really is an absolute marvel of human engineering and coordination, and it's all securely built on this secret language. Thanks for joining me on this explainer, and keep looking up.